Okay, guys, let's look at 9.5, the rest of the section here, graphing secant and cosecant functions. And remember, cosecant is the same as 1 over sine of x. And secant would be the 1 over cosine of x. Say we're looking at secant x or the cosecant of x, right? Okay, so really we graph all these by just graphing, say, their reciprocal function, and then we'll look at what we do from there. So let's look at an example here, 2 secant of x. Well, I'm really going to start by graphing its reciprocal function, which would be cosine, right? So let's do 2 cosine of x. Okay, and it's got an amplitude here of 2 and a period of 2 pi over the absolute value of b, and remember that's 1. So period is 2 pi over 1 is 2 pi. All right, and let's graph that. And maybe we'll do a couple periods worth. Okay, so we start at 0 and we're going to go up to its period length here of 2 pi. All right, and how much did we add, say, from 0 each time? Well, we did 2 pi divided in 4 pieces, pi over 2. And let's divide it in 4 equal sections. Okay, so 0 plus pi halves is pi halves. Pi halves plus pi halves is pi. Pi plus pi halves is 3 pi halves. And 3 pi halves plus pi halves is 2 pi. Remember, we're adding whatever this period length divided in 4 pieces, 4 equal sections, we're going to add that to wherever we start each time. Okay. And if we wanted to, say, go in the negative direction, we could. Negative pi halves. Negative pi. Negative 3 pi halves. And negative 2 pi. Okay, so, and we've got 2 period lengths, and if we went from 2 pi plus pi halves, that'd be 4 pi halves plus pi halves, that'd be 5 pi halves. 3 pi, 7 pi halves, and eventually to 8 pi or 8 pi halves or 4 pi. Okay. Now, if we went to graph this, we could, of course, evaluate points. I know that, say, the cosine of, say, 0, starting here at 0, cosine of 0 is 1, because 0 on the unit circle, the x value is 1. So 1 then times 2 is 2. So I know I should be up here at 2. And if I studied my sine and cosine graphs, I know I'll go like this, down like this, up like this, and back up to where it began after one period. So I'm going to go ahead and draw that in now. Okay, and that's one period's worth. And of course we could, if we wanted, we could just keep going, and I know it'd then go down. That's why you find all these intermediate locations, because then you can construct multiple periods worth relatively easily. Once you know, say, the pattern of. And if it keeps going here, sorry, up here too. Okay, so that's what our cosine, 2 cosine of x. Notice it's got an amplitude here of 2, which means it goes up 2 from the midline in either direction. But of course, since it's cosine, it started here at the y-axis here at 0, its amplitude, 0, 2. And then it went down from there. Notice cosine graph starts at your positive amplitude. Sine graph starts at your midline, or the x-axis in this case. Okay. After the cosine of x, 2 cosine of x, then we can look at 2 secant of x. So remember, we're going to graph its reciprocal function first, which if it's secant, that's cosine, and if it's cosecant, then that's sine. So notice I did 2 cosine of x here first. And now let's look at what 2 secant of x looks like here, our original. Okay, so now what we want to do is put in these asymptotes every time it intersects our midline. Okay, so I'm going to go ahead and do that at every time. So they're at pi halves and negative pi halves. Where else? 3 pi halves. 5 pi halves, 7 pi halves, and so on. Anytime, negative 3 pi halves over here. Okay, so those are vertical asymptotes. And remember, with vertical asymptotes, those are lines that our graph is going to approach but not cross. So we want to make sure that once we draw our, say, secant, we don't cross those lines. Okay, now, secant's essentially going to take a parabolic form here, and it's going to touch at whatever, say, our minimum or maximum is. So let me draw one in. Let's draw another one. Touches, and then goes up there. Touches, goes down now in both directions there. Touches, increases in both directions there. And so on and so forth. So notice it's going to come up. It's going to touch at those locations there, which are minimum or maximums or peaks and troughs there. And then it's not going to cross, but it's going to touch at this same point here. I'll go ahead and show you. Okay. And then it's going to go off in directions away from it, approaching, but never then reaching those asymptotes which it's bound by on either side. Okay, so this is what a secant graph looks like. And remember, familiarize yourself with some other characteristics on page 500, the core concepts. Just read through the domain and range and how that represents. But this is how they're constructed. You're going to say graph, what if it's secant, you're going to graph the cosine graph and try and do a few periods worth. Try and do them in either direction. And then draw in, say, your secant from there. Okay, and remember your secant graphs are actually all these, right? So the other graphs you're just drawing to kind of give shape and form to what is your secant graph. But the actual secant graph are what's here in blue, okay? Okay, so I hope this helps you get started in 9.5. Thank you.